Next speaker is actually going to talk about Jetstream2. So I thought this was a great segue. We do have a new program called the Jetstream2 AI Fellows Program. It is open to researchers and grad students. I'm just going to quickly flip through these 4 images because tonight at the swanky reception that you're all going to go to in the State Museum, you can pick up a print flyer if you know of folks who might be good to apply for the Jetstream2 AI Fellows Program. A few things about it, $5,000 stipend. Okay, moving on. Kevin, I'm going to let you introduce yourself and take it away. Thanks, sir.
All right, thanks so much, Robert, and thanks everyone for joining. Certainly happy to be here to present on what when I first had the opportunity to find out about this conference, and one of the things that was asked for were use cases of open infrastructure and OpenStack. So it's like, hey, I've got a great story to tell. So I will be talking about how I've been involved with a project that uses OpenStack to provide a persistent BinderHub instance on Jetstream2. So I'm someone whose last name has always been at the end of the alphabet, so I'm actually going to go in reverse order here. So my contributors here, Brian Rose of University of Albany. He is the lead PI of Project Pythia, which I'll be talking about shortly. Andrea Zonka from San Diego Supercomputing Center. All the work that I'll be describing to you certainly would not have been possible without the great tutorials and recipes that Andrea has whipped up. Also, I seem to have lost my slides here. So I'll tell you a little bit about myself. I am at the University of Albany's Department of Atmospheric and Environmental Sciences. I'm kind of the IT guy, wear a bunch of different hats in the department, teach a couple of classes on data analysis and visualization using the Python stack. And the project that I do in kind of my spare time is Project Pythia. Project Pythia is, we're now in our 4th year of funding, and the goal here is to provide a platform for geoscientists, wherever they are in the OpenStack, wherever they are in their educational workflow, whether they're undergrads all the way to scientists. Whole bunch of tools that are available to us in Python. How can we bring people up to speed using that? So the naming has some origins. You may actually see a little bit of the Greek architecture here. The legend involves a slaying of Python. No, we've kind of evolved a little bit. We don't want to slay the Python. Instead, we want to work nicely with Python, and that is what Project Pythia brings to us. And the task that we have all of this data. Just in the last panel that we heard, talked about the 80-20 rule. Well, we have another 80-20 rule, and that is scientists typically spend 80% of their time working with the monumental amount of data that is out there, but only 20% to actually do the work that they were funded to do. And so Project Pythia tries to make it a little bit easier, bringing together workflows and computational notebooks that are not only reproducible, but also extendable. And so let's see here. We have several questions here that Project Pythia attempts to resolve. I'm going to talk specifically of how Jetstream2 has made, our work with Jetstream2 has made that possible, and particularly how can we work with big data sets. While one can download a Jupyter notebook that perhaps someone has developed and hosted on their GitHub, Actually having the capability to work it on your own laptop can be difficult and challenging. So the two bolded items there are particularly what we have done with our Jetstream2 project. What has been our main effort over the last few years are what we call cookbooks, a selection of individual Jupyter notebooks that perhaps may illustrate a workflow with a particular geoscience Python ecosystem package, such as Xarray or Cartopy, but also how can we do reproducible science? Perhaps we have someone who's working with climate data, working with climate models, doing climate simulations, visualizing the data. How can someone else go through and run the same set of Jupyter notebooks without having to worry about building a software environment, a Python environment on their own laptop? So we call these cookbooks, and we have about 19 or so presently available to us. They are available on our projectpythia.org webpage. We see several examples here, and I'll be going through hopefully a little bit of an animation that shows how one can load and run on Jetstream2's resources. So we have a workflow that involves spinning up Jupyter hubs and using a technology called BinderHub. BinderHub actually allows for environments that define a particular set of packages in the Jupyter ecosystem. And by loading them through a container, we can actually spin them up. We have one example here, just developed over the last couple of months using biogeochemistry in the context of a climate model. So Jetstream2, anyone here has heard of Jetstream2? Yeah, I kind of thought so. So not going to spend much time on this particular slide. But let's say we want to, how did we actually do the task? So with Andrea's help, we have, we basically are deploying Kubernetes on Jetstream2 with a set of recipes that Andrea has developed, mostly leveraging Terraform and Ansible. And the beauty for someone like me wants to have many things that I've got to do at the same time. All really I had to do is follow and execute recipes that Andrea has developed and are hosted right on Jetstream2's tutorials. So pretty much what happens, we have perhaps one user who wants to run, interact with several of our Project Pythia cookbooks. Essentially, Kubernetes makes a BinderHub instance available, and then the particular notebook or cookbook that is spun up reads in a container. All of the work of putting together, constructing a Python environment is done for you, and the user can then run through the notebooks. So so we have one example here. Also, all of the notebooks are then pointing to all of the Docker containers that we have that define a particular Project Pythia cookbook hosted on BinderHub. The user then selects whatever cookbook they want to run, and the BinderHub then loads the image from Docker Hub and then spins it up. One of the other things that we are using with Jetstream2 provides object store, and I've just heard that it's one of the largest object store, Ceph, open source object store collections in the country. So we have been in terms of data sets that may be on the order of several terabytes, we actually can point to it just using the object store on Jetstream2. So imagine you have a climate model run data set that is present. We can actually have data that is located right on where the compute is. So we have an example of that there. And let's actually see how this is done in a real life situation. So, yeah, well, this is actually not a live demo, but just a demo. Let's see if I can get that to. Sorry about that. Yep. Sorry about that, folks.
Nothing to see here, folks. Do you have a Google account you can turn into?
Yep. Yeah, we will find out. It was. Oh, nope.
Is that your email?
Yeah.
Not your password.
Not my password.
Everybody, quick, go to his bank. All right, now it's hiding.
Hey, all right, let's see if this works. Thank you. All right, so let's say we're on the Project Pythia page. We go to Cookbooks Gallery. I'm going to pick one that actually I authored myself, so I have some idea what it's going to do. So what a user can do is just click on the nice fancy launch binder. There we go. How this works in action. It's actually retrieving the Docker image that contains the complete environment for this particular cookbook. Loads it up. So none of this has had to be done on your own laptop. It's all running on Jetstream2. And in this particular case, we are loading some high resolution weather forecast data from NCEP at NOAA. We can run the notebook then to completion. We can see all the cells already executed. There's our temperature map as an image map, but here is a more useful display. And that is an example that has that was dated from a few years ago. What we now allow the user to do is, okay, I want to rerun this notebook. I want to explore it. Perhaps I want to change it. A trivial change that one can do is just pick a different date. That is what we are doing here. So I've just rerun the date for a couple of days ago. And here is a current weather map. And obviously all we've done in this particular notebook is allow the user to make one trivial change. But what we have with Jetstream2 is allow the user to change and interact and add depending on what they would like to do. So this is just one example here. We have about 19 or 20 cookbooks that are available. Going back to the presentation now. And I seem to have lost that as well. All right, need to get back to the.
This is why I get paid the big bucks.
Just want to go to the next slide.
What if I don't want to request access? No. Oh, nope.
There we go. So we used the infrastructure on Jetstream2. We've done this now for 3 years in what we call a Pythia cookbook hackathon. We call it a cook-off. Participants from across the country, from all levels, from undergraduates all the way through scientists, come and create content for our Pythia cookbook gallery. And kind of the nice thing here is that all of the work that was done during this hackathon was done on our Jetstream2 instance. And so serving about 50 or 60 folks, both in person and hybrid, and everything kind of just worked. One of the things with using OpenStack, I've just kind of deployed a few of the recipes that Andrea has developed. And sometimes not having a lot of direct experience with, say, Kubernetes or OpenStack can seem a bit intimidating, especially if things don't work, but happy to say that everything kind of did work. And here we had examples with we even had some undergraduate students. Part of what we have in Project Pythia, not only are we doing scientific exploration, but we have a set of foundational tools that introduce students not only to some of the core geoscience Python ecosystem, but also to skills such as using Git and GitHub. So I think in the previous session I was in, Billy Olson stated that less than 10% of students coming out of undergraduate programs have really any experience using Git on the command line. Well, we had a few undergraduates from my program at Albany and kind of put together, as they constructed their cookbooks, worked through and started to master just putting together Git repositories and then uploading them and then seeing their work come and be shared with others on Jetstream2. So some of the future work that we're doing, adding even more reproducibility and interactivity using Mist. And that is a project that is being used by CurveNote and Executable Books. We are in a first year of our second phase of awards. We had one 3-year award from EarthCube. We now have a second 3-year grant. A lot of the effort now is working towards additional cookbooks and kind of mystifying them and creating cookbooks that not only are reproducible, but also can be cited as scholarly objects. So one of the things we're working on is developing kind of a more formal review criteria, because this is an open project. Anyone can contribute to it. The link is there. And so coming up, we've been using a Discover Access allocation in order to power our Jetstream2 BinderHub. So coming up, we're going to ramp things up a little bit with an Accelerate Access proposal. And just heard about some dynamic scaling using Cluster API. As we add more and more computationally complex use cases to our cookbooks, we're going to need to have ways to kind of easily dynamically allocate resources to handle things such as GPU for AI and ML. Also do some advanced monitoring using tools such as Prometheus and Grafana, and always come out of these conferences with some new tools that I need to learn. So Mohammed talked about vector and loci. I'll be adding that to my list of things to explore. So I'd like to thank Jetstream2 for all the resources they have provided, and especially the NSF Access Program. I'm a campus champion for University at Albany, and as a result, they were able to fund my participation at this conference. So thanks much for your time. Sorry for the little technical hiccups there. And there is a QR code for Project Pythia there on the screen for you. Thank you. Yo.